All right, students, this is the week 20 video. If you are missing anywhere from week 20, you won't need to be watching this. I am going to go through it quickly, but remember that you can pause at any time to write whatever it is you need to write. So don't feel like you need to keep going with the video and try to speed through everything. Just take a moment, pause, and do something if you need to do it. All right, so number one on the week 20 workbook was on page 2 of the workbook, and it's a definition. The combination of all forces acting on an object, because we know that a lot of times more than one force can act on an object at the same time. That combination is called the net force. Okay. Number 2 is over on page 11. And it says, explain what happens when forces push in the same direction. And if you look right here in the text, it says when forces push in the same direction, they add together to form the net force. Okay, so you should write here, when forces push in the same direction, they add together to form the net force. So remember, pause it if you need to write that down. I'm going to continue. 3 is this foldable. The main reason a lot of people miss this foldable on there when we're getting checked is because they didn't describe and sketch. You need to make sure you do that and say examples of balanced and unbalanced forces. They give you some examples here of a balanced force or an unbalanced force. It says when you push on the opposite side of the dresser with then maybe your friend, if one of you is pushing harder, then the forces are going to be unbalanced, and then the dresser is going to move in the direction of the person that's pushing the hardest. Okay, so that's describing an unbalanced force. It says now if both of you were pushing in opposite directions, but you were pushing with equal forces, then the force would be 0. Okay, and then the dresser wouldn't move, and those forces would be balanced. So that's a description of both right there in the text. And then it says to sketch. You can kind of sketch you and your friends pushing with different amounts of force, making sure you use arrows, or you can look down here. Here's an example. Let's say this was the dresser, you and your friend pushing with the same amount of force. That would be balanced. Or if you were here, if this was you and this was your friend and you were pushing with more force, you can see that this arrow is bigger, indicating more force. The dresser would move in that way. And because your forces are unbalanced, this object is going to move. Okay, so that's something that you might want to draw or sketch in this foldable. So again, if you need to pause and do that, please do so. So that was 3, 4 is right here. Okay. Again, a lot of people miss this because if you simply read the directions, it'll help you out a lot. It says organize information about contact and non-contact forces using the diagram. I saw people put all kind of stuff in these 2 bubbles, but the forces can be broken down into 2 major categories: contact forces and non-contact forces. And it said that right there. So if you have something different in these boxes, you need to change that. And how do we know that contact force goes in this bubble? Because one example that they give us is a tow truck pulling a car. If a tow truck is going to pull a car, it actually has to be in contact with the car. So we know that contact needs to go there. They'll actually be touching. Okay, another example, and you can think of a million examples here, but a book sitting on a table. The book is actually in contact or touching the table, so that's a contact force. In the text, they say there's a few non-contact forces. One example being gravity. Gravity attracts all things. The earth is attracted to the sun, but they are not actually touching. If you throw a ball in the air, the force of gravity pulls it back down towards the earth, even though that while it's in the air, they aren't touching, but gravity is still there. So it's a non-contact force. The magnetic force is another example of a non-contact force, as well as the electrical force. Okay. Number 5. Okay, you can pause this and take a look here at what I've written, but it says for you to draw examples. It says draw an object or make 2 drawings, one here and one here, of an object affected by balanced and unbalanced forces, and use arrows and labels going in opposite directions to show. So you can see this arrow is going to the right, this one's going to the left. Look over here too. This one's going to the right and the left. So I've used my arrows and they're going in opposite directions, okay, and labels. Okay, so here I'm showing that I'm labeling it, showing there's no motion because the net force is 0. And if we assigned a number to these, they would have to be the same. So if this was 10 newtons, this would have to be 10 newtons because it's balanced. And then when the net force is 0, there's no motion. Over here, here we see that this one is a lot more force than this little tiny one over here. And because this one is going to the right is bigger, the net force in this example is going to be to the right. And then I've just described what's going on down here. You can pause that if you want and write it. Over here, this is a true false. It says when the net force on an object is 0, the forces are unbalanced. But we just learned that when the net force is 0, the forces are balanced. Okay, so that's false. That's why we corrected it. 7. Again, we did this when we did the flow chart. It says the force exerted when objects are not touching. Okay, when they're not touching, that would be a non-contact force, so this answer would be E. Right here, it says the blank of an object is a force. Well, it's not mass because that's the amount of matter that's in an object. Okay, and it's not motion because motion doesn't have both size and direction. It just has direction. And we know what force is a vector. Involved vectors have size and direction, so it has to be weight. All right, and the weight of all objects is the direction towards the gravity. So for example, your weight is whatever you weigh, and the direction is toward the center of the earth. So weight is a force. It has magnitude or size and direction. It says here, magnetic force is a type of, we already talked about this, that's a non-contact force. Magnets don't have to be touching objects to exert a force on them. And it says when one or more object forces act on the object, the forces, we talked about this, they combine to give you the net force. So hopefully you're seeing how all these things add together. So that's week 20. Those are the 10 things we graded. If you need to go back and do something, do that, pause it, make sure you get it done quickly and move on.